Hey dear viewers, welcome to this session of our YouTube channel. Welcome to our session. Today's topic is all about deriving a few general rules for the rectangular form of a complex number. To achieve our goal, we're going to consider an arbitrary complex number. Okay, so the arbitrary complex number that we're going to choose is z equals to a plus bi. We're going to use this arbitrary complex number to derive a few general rules for the following expressions. The first expression is z plus z bar. I hope you still remember what z bar stands for. Okay, so remember that z bar stands for the complex conjugate of z, and remember that the complex conjugate of z is obtained by changing the sign of the imaginary part of the complex number z. So we're going to have the complex conjugate of z to be equals to a minus bi. Therefore, to obtain an expression for z plus z bar, we're going to have a plus bi plus a minus bi. You can see that bi we cancel with bi on the side. We're going to have 2a, as simple as that. So the general rule for the expression z plus z bar is equals to 2a. You see that this complex number has just got the real part. Now let's derive a rule for the expression z minus z bar. So z minus z bar is equals to a plus bi minus, we put everything in the bracket, a minus bi. We open up the bracket to obtain a plus bi minus a plus bi. Therefore, a we cancel with a. We're going to have 2bi. So the general rule for the expression z minus z bar given the complex number z equals to a plus bi, the general rule is that z minus z bar is equals to 2bi. So we see that this expression has only the imaginary part. Okay, let's move on now to the expression of the general rule for the expression z times z bar. So this gives us a, okay, a plus bi times a minus bi. Okay, this equals to, remember how we multiply, we're going to have a squared here. We're going to have a times a gives us a squared. A times minus b gives us minus, a times minus bi gives us minus a bi plus a bi minus b squared. Okay, you have b squared times I squared. Okay, remember that I squared gives us minus 1, right? So we're going to obtain a squared. We can also see that this expression in the middle cancels with the same with this expression in the middle here. So we're going to have a squared plus b squared, simply because I squared is indeed minus 1. So we're going to have minus b squared times minus 1 to obtain plus b squared. These are a few general rules for this expression that we've studied so far. Let's consider a few more before we end up our session. So we're going to consider the general rules for the expression z squared given that a plus bi, given that z equals to a plus bi. Okay, so we're going to have the general rule for the expression z squared equals to a plus bi, okay, times a plus bi. Remember how we multiply complex numbers? So we're going to have a squared plus a times bi plus again a times bi. This time around we're going to have plus b squared times I squared. So we're going to have a squared plus 2ab I. Remember, I squared equals to minus 1, so we're going to get minus b squared. So we collect the real parts together, so we're going to have a squared minus b squared plus 2abi. And that's the general rule for this expression z squared, given that z equals to a plus bi. So let's obtain a general rule for the expression, the real part of z squared. So remember, the real part is that part without the I. So we come back to this z squared we've obtained. We can say the part without the I is indeed a squared minus b squared. This is simply equals to a squared minus b squared. And what is the expression, or what is the rule for the expression, the imaginary part of z squared? We will just simply have that part with, or the coefficient of I squared in this expression, which is indeed, we can just write the imaginary part of z squared is simply equals to 2ab. As simple as that. So if you understand complex numbers, this type of game will be very, very easy to play. So thank you for following up to this point. We'll advise you to like, share, comment, and why not subscribe to this YouTube channel. So like, comment, share the video, subscribe to this YouTube channel. Once more, thank you for following up to the end. See you in the next video. Bye.